What specific problem does your proposed framework for generating synthetic users aim to address in the context of health coaching agents?
The proposed framework for generating synthetic users aims to address the challenge of realistic user simulation in health coaching contexts, particularly the need for diverse and representative user interactions that reflect specific health conditions and demographics. By utilizing real demographic, health, and behavioral data, the framework generates synthetic users that exhibit health conditions consistent with their assigned attributes, allowing for more accurate and relevant interactions with coaching agents. This approach mitigates the limitations of previous studies, which often relied on small sample sizes and generic synthetic users, by ensuring that the generated personas are grounded in reality and can effectively reveal shortcomings in coaching agent performance. Additionally, the framework incorporates domain-specific information, such as barriers and goals, enhancing the realism of the interactions and enabling better evaluation of coaching agents' efficacy. Ultimately, this framework accelerates the development and assessment of health coaching agents by providing a scalable and cost-effective means of simulating user interactions.
How does the proposed method work? Illustrate the step-by-step process from the generation of vignettes to interaction with coaching agents.
The proposed method for generating synthetic users begins with the collection of real demographic, health, and behavioral data to create a representative cohort. From this cohort, natural language vignettes are generated, which encapsulate key attributes such as health conditions, barriers, and goals, ensuring they reflect the specific demographics and behavioral factors of the target population. These vignettes are then used to instantiate synthetic users within a generative agent-based model, specifically the Concordia system, which manages the interactions between the synthetic users and coaching agents. During the interaction, the coaching agent utilizes the internal user model to identify the synthetic user's primary concerns and barriers, achieving high accuracy in recognizing these attributes. Finally, the effectiveness of the synthetic users is validated through evaluations by human experts, who assess the realism and relevance of the interactions compared to baseline synthetic users generated from demographic data alone.
Can you provide a specific example of a synthetic user vignette generated by your framework, detailing the attributes included and how it reflects real-world data?
One specific example of a synthetic user vignette generated by our framework is a synthetic user created for sleep coaching, which utilized the LifeSnaps dataset. This vignette included attributes such as primary sleep concern, which might be difficulty falling asleep, sleep goals like achieving 7 hours of sleep per night, reasons for goals such as to improve daily energy levels, and barriers like stress from work. These attributes were derived from real demographic data, sleep duration, efficiency, and behavioral characteristics of individuals in the LifeSnaps dataset, ensuring that the synthetic user accurately reflects the complexities of real-world sleep issues. The generated vignette was then used to simulate interactions with a sleep coaching agent, allowing for a realistic representation of user needs and challenges in a coaching context.
What are the key advantages of using your synthetic user generation method compared to existing user simulation techniques in health coaching?
The key advantages of our synthetic user generation method compared to existing user simulation techniques in health coaching include the ability to create realistic user profiles grounded in actual health, lifestyle, and behavioral data, which enhances the authenticity of interactions with coaching agents. Our framework allows for the incorporation of specific health conditions, barriers, and goals derived from comprehensive datasets like the LifeSnaps and Project Baseline Health Study, ensuring that the synthetic users reflect the complexities of real-world health challenges. Additionally, we utilize a structured approach to generate detailed vignettes that include demographic, psychological, and behavioral attributes, which contrasts with previous methods that often relied solely on generic demographic data. This results in synthetic users that not only demonstrate accurate health conditions, but also communicate effectively, as validated by human expert evaluations, showing significant preference for our full synthetic users over baseline models. Finally, our method facilitates the identification of coaching agent shortcomings through user feedback, providing a robust mechanism for evaluating and improving agent performance.
In your experiments, how did you validate the effectiveness of the generated synthetic users in interaction with the coaching agents? What specific metrics or evaluation methods were used?
In our experiments, we validated the effectiveness of the generated synthetic users through several methods. For the sleep coaching domain, we compared the internal user state of the coaching agent against the true sleep profiles assigned to the synthetic users, achieving an accuracy of 89.7% in identifying primary sleep concerns. We also computed recall and precision metrics for barriers and sleep goals, obtaining mean recall of 71.4% and 66.4%, and mean precision of 72.5% and 84.2%, respectively. Additionally, a human expert evaluation was conducted, where evaluators preferred interactions with our full synthetic users over a baseline that used demographics only, with a highly significant p-value of 3.7 times 10 to the power of -12. In the diabetes coaching domain, expert evaluations confirmed that the synthetic users effectively demonstrated the barriers they were designed to portray, with 100% agreement on this aspect, and a preference for our full synthetic users over baseline users in demonstrating the correct original barrier.
What limitations does your framework have in terms of the types of health conditions it can simulate or the diversity of the generated synthetic users?
Our framework has limitations regarding the diversity of health conditions it can simulate, primarily due to the reliance on existing datasets, such as the LifeSnaps dataset for sleep conditions and the Project Baseline Health Study for diabetes. These datasets may not encompass the full spectrum of health conditions or demographic diversity, potentially skewing the representation of certain populations. Additionally, while our framework allows for the generation of synthetic users with specific health conditions, the underlying data may not capture all relevant barriers and challenges faced by individuals in real-world scenarios. Furthermore, the instruction fine-tuning of large language models, LLMs, can impact the distribution of generated outputs, leading to a lack of representation for underrepresented subgroups or conditions. Lastly, the framework's effectiveness in simulating interactions is contingent on the quality and comprehensiveness of the input data, which may limit its applicability across various health domains.